Hello students, how are you? I hope all of you are good. In this video, I am going to discuss the property of the definite integral. That is what? Integration from a to b fx dx is equal to integration from c to a fx dx plus integration from c to b fx dx. So in this property, the integral limits from a to b as breaked into a to c and then c to b, where C is greater than A, less than B. See here, as I discussed in my introduction class of the properties of definite integral, so mainly the definite integrals are used to find out the area bounded by a curve. So for example, suppose this is a x-axis and y-axis. Y equal to fx is a curve of any function which is defined from x is equals to a to x is equals to b. So to find the area A, B, C, D, we use what? Definite integrals. So this area A, B, C, D is equal to area of A, B, C, D is equal to what? Integration from A to B, fx dx. Or if suppose if we know the value of x in between a and b, suppose we introduce another point x equals to c. So required area a b c d is now divided into two parts, that is what? From a to c and then c to b. So therefore this entire required area a b c d is also calculated by using another method, that is what? Area of a b c d is equals to integration from a to c, integration from a to c fx dx plus integration from c to b, fx dx. So this also gives what? This entire area abcd. So first one is also gives what? Area of abcd. It means both of these two quantities are equal. So this is what this property is saying here. That is what? Integration from a to b fx dx is equals to integration from a to c fx dx plus integration from c to b fx dx. I hope all of you understood the application of this property. Now what? Here the question is prove this property. So now I am going to prove this property. To prove this property, first I would like to consider the value of integration of the function here. So let us consider what? Let us consider integration of this function fx dx is equals to some other function, that is what? Phi of x plus c. So now to prove this property, let us consider LHS. Let us consider LHS. What is LHS here? LHS is equals to integration from a to b fx dx. Now see here, as I considered here, integration of fx is pi x plus c. Therefore, integration of fx is what? Pi of x. Since this is a definite integral, no need to write plus c. And over the limits what? A to b. Over the limits a to b. So after integrating, use the limits. So the way of using limits is what? Upper limit minus lower limit. So these limits are the values of x. Therefore, substitute this value of x in place of x in such a way that upper limit minus lower limit. Nodri hengaagtadini? Pi of b upper limit minus lower limit is what? Pi of a. So this is what? LHS of the property. And then next consider the RHS. What is RHS here? RHS of the property is integration from a to c fx dx plus integration from c to b fx dx. So now same thing, first integrate this fx. Integration of fx is what? Pi of x over the limit a to c plus integration of fx is pi of x over the limit c to b. Next what? Use the limits. Upper limit pi of c minus lower limit is pi of a plus in second one also upper limit minus lower limit pi of b minus pi of c. So So in this equation, observe here I can cancel pi of c minus pi of c. So after cancelled, we have RHS is equals to pi of b minus pi of a. So call it as equation number 2. Now compare this first and second equation. The LHS is pi of b minus a and RHS also pi of b minus pi of a. Therefore, from the equation number 1 and 2, we conclude that from equation 1 and equation 2, we conclude that what LHS is equals to RHS. It means integration from a to b fx dx is equals to integration from a to c fx dx plus integration from c to b fx dx. I hope all of you understood how to prove this property. And now let us consider some of the problems which are solved by using this property. One more thing, mainly this property is used to integrate the modulus functions and greatest integer functions. Let us consider the first question. Evaluate integration from minus 5 to plus 5 modulus of x plus 2 dx. Here integrating function is what? Modulus function. So let us consider this given integration problem is I, and I is equals to integration from minus 5 to plus 5 modulus of x plus 2 dx. So by using the property, first we need to break these limits. So to break the limits, we know the definition of modulus function. So what is modulus of x plus 2 here? We know that modulus of x plus 2 is equals to modulus of x plus 2 is equals to plus x plus 2 when if x plus 2 is greater than or equal to 0, it means what? X is greater than or equal to minus 2. And the value of modulus of x plus 2 is minus of x plus 2. Yavaga, if x plus 2 is less than 0, when x is less than minus 2. It means I am going to break the limits from minus 5 to minus 2 and then minus 2 to plus 5. Therefore, by using the property, this integration problem I can be expressed as integration from minus 5 to minus 2 plus integration from minus 2 to plus 5. And one more thing, when we are integrating from minus 5 to minus 2, it means we are integrating at the limits less than minus 2. When x is less than minus 2, what is the value of modulus x plus 2? Minus of x plus 2. Therefore, here I am going to integrate what? Minus of x plus 2 dx. And here from minus 2 to plus 5, it means greater than minus 2. When x is greater than minus 2, what is the definition of modulus of x plus 2? X plus 2. Therefore, x plus 2 dx. I hope all of you understood how to break down the integral limits when we are integrating the modulus function. What next? Simply we need to integrate this function and apply the limits. See here. Firstly, I am going to take this minus sign outside the integration sign, minus of. And then what? Integration of x plus 2. Integration of x is x square divided by 2 plus integration of 2 is 2x over the limit minus 5 to minus 2 plus same thing here also integration of x is x square by 2 plus integration of 2 is 2x over the limit minus 2 to plus 5. So after what? Just apply the limits. So minus as it is, minus as it is. Now see here ಏನು ಮಾಡತ್ತೀನಿ ನೋಡ್ರಿ ನಾನು minus as it is upper limit is what? Minus 2. When we substitute the value of x is minus 2, minus 2 square is plus 4 divided by 2 plus 2 into minus 2 is minus 4. Upper limit completed. Minus lower limit, when x is minus 5, x square is 25. So 25 divided by 2 plus 2 into minus 5 is minus 10. I hope all of you understood. So we completed applying the limits for the first one and then plus same thing we need to apply the limits for the second one also. Upper limit is 5. So 5 square is 25 divided by 2 plus 2 into 5 is 10 minus lower limit. What is the lower limit? Minus 2. Minus 2 square is 4 by 2 and then 2 into minus 2 is minus 4. I hope all of you understood. So in the next step, nodri nanu ಏನು ಮಾಡ್ತಾ ಇದೀನಿ, in the next step I is equals to minus of, see here 4 by 2 is 2 minus 4 minus minus 25 by 2 minus 10. LCM is 2, here multiplied by 2. So 10 into 2 is 20. 25 minus 20 is 5 divided by 2. Plus here also same thing. LCM is 2. 2 into 10, 20. 20 plus 25 is 45 divided by 2. Minus 4 by 2 is 2 minus 4. I hope all of you understanding. So now see here in the next step, I is equals to, see here, ಹೊರಗಡೆ ಇರೋ minus as it is into 2 minus 4 is minus 2 minus 5 by 2 minus 5 by 2 plus here also same thing 45 by 2 45 by 2 and then minus as it is 2 minus 4 is minus 2 minus into minus plus 2 which is equals to multiplied this minus into minus 2 plus 2 minus into minus 5 by 2 plus 5 by 2 plus 45 by 2 plus 2. I hope all of you understanding. Now see here 2 plus 2 is 4 plus 5 by 2 plus 45 by 2 is 50 by 2. Therefore answer is equals to nodri 4 plus 50 by 2 is 2 ones are, here I can cancel 2 ones are 225. So 4 plus 25 which is equals to what? 29. Therefore the value of this integration problem is equals to what? 29. I hope all of you understood. Now let us consider the second question, and the question is evaluate integration from 2 to 8 modulus of x minus 5 dx. So here firstly I am going to consider this integration problem is I, and what is I? Integration from 2 to 8 modulus of x minus 5 dx. Again same thing by the definition of mod function. Value of modulus x minus 5 is equals to plus x minus 5 yavaga if x minus 5 is greater than or equal to 0. It means x is greater than or equal to 5. And value of this mod x minus 5 is minus of x minus 5 yavaga if x minus 5 is less than 0 and x is less than 5. So it means I am going to break this integral limits from 2 to 5 and then 5 to 8. I hope all of you understanding. Therefore I is equals to integration from 2 to 5 ಯಾವ ಪಾಯಿಂಟಿಗೆ ಬೇಕಾಗ್ಲಕತ್ತದ at 5. So 2 to 5 plus integration from 5 to upper limit 8. I hope all of you understanding. In integral limits 2 to 5 means we are discussing for less than 5. When x is less than 5, definition of modulus x minus 5 is minus of x minus 5. So here minus of x minus 5 with respect to x. Plus integral limits from 5 to 8 means more than 5. When x is more than 5, definition of mod x minus 5 is x minus 5. So x minus 5 dx. I hope all of you understanding. What next? Simply integrate and apply the limits. So first thing, taking minus outside the integration side, and then integration of x is x square by 2 minus integration of 5 is 5x over the limit 2 to 5 plus integration of x is x square by 2 minus integration of 5 is 5x over the limit 5 to 8. I hope all of you understanding. And then use the limits. Minus as it is, upper limit is 5, 5 square is 25 divided by 2, minus 5 into 5 is 25. So upper limit completed. Minus lower limit 2 square is 4, 4 divided by 2, minus 5 into 2 is 10. So we completed the first part. Plus second part note again same thing, 8 square is 64, so 64 by 2, minus 5 into 8 is 40, 5 into 8 is 40, minus lower limit 5 square is 25 divided by 2, minus 5 into 5 is minus 25. I hope all of you understanding. Now in the next step, minus of see here, LCM is 2, 2 into 25, 50. So 25 minus 50 is minus 25 divided by 2. Here 2 ones are 2 twos are, so 2 minus 10 is minus 8, and minus into minus 8 is plus 8. We completed the first one. Plus second one nodri, 64 by 2 means 2 ones are 2 32s are, 32 minus 40 is minus 80, and then minus LCM is 2, 25 into 2 is 50, so 25 minus 50 is minus 25, minus 25 divided by 2, minus into minus plus 25 divided by 2. I hope all of you understanding. So in the next step, the integral value I is equals to, see here, minus into minus 25 by 2 plus 25 by 2 minus into plus 8 minus 8 plus into minus 8 minus 8, and then plus into plus 25 by 2. I hope all of you understanding. So I is equals to, see here, 25 by 2 plus 25 by 2 is 50 by 2 minus 16. I hope all of you understanding. Now I is equals to 50 by 2 means 25, because 2 ones are 225. So then 25 minus 16, the value of 25 minus 16 is equals to 9. Therefore, the value of this given integration problem is 9. I hope all of you understood. Now let us consider one more example based on the same property. And the question is, evaluate integration from 0 to 4 modulus x minus 1 dx. So firstly, I am going to consider this given integration problem is I equals to integration from 0 to 4 modulus of x minus 1 dx. Firstly, I am going to break the limits. That's why I am going to use the definition of modulus function. So we know that modulus of x minus 1 is equals to plus x minus 1 yavaga if x minus 1 is greater than or equal to 0. It means x is greater than or equal to 1. And modulus x minus 1 is minus of x minus 1 yavaga if x minus 1 is less than 0. It means x less than 1. I hope all of you understanding. So it means I am going to break the integral limits. Firstly 0 to 1, and then 1 to upper limit 4, because this mod function dividing at point x equals to 1. So now I can express this I as I is equals to integration from 0 to 1 plus integration from 1 to upper limit 4. So in the integral limits 0 to 1, it means less than 1. When x is less than 1, mod x minus 1 is minus of x minus 1. So minus of x minus 1 with respect to x. From 1 to 4 means more than 1. When x is more than 1, mod function is equals to x minus 1. Therefore, x minus 1 with respect to x. I hope all of you understand. Again, same thing, integrate and apply the limits. First thing, taking minus outside the integral sign, and then integration of x is x square by 2 minus integration of 1 is x over the limit 0 to 1, plus here also integration of x is x square by 2 minus integration of 1 is x over the limits 1 to 4. Now I am going to use the limits. I is equals to minus of, nodri upper limit is 1, 1 square is 1, so 1 by 2 minus x is 1, upper limit, minus lower limit is 0, 0 by anything is 0, minus 0, so 0, plus same thing here also, upper limit is 4, 4 square is 16, so 16 by 2 minus 4, upper limit, minus lower limit, 1 square is 1, 1 by 2 minus 1. I hope all of you understood. Now what? We need to simplify this to get the value of I. To get the value of y, what is the next step? I am going to simplify this. Therefore, I is equals to, see here, minus of Here LCM is 2, 2 into 1, 2, 1 minus 2 is minus 1 divided by 2, and then minus 0, leave it, plus, plus 16 by 2 is 8, minus 4, and then minus, minus, see here LCM is 2, 2 into 1, 2, 1 minus 2 is minus 1, minus 1 divided by 2. I hope all of you understanding. Therefore, I is equals to, therefore, I is equals to minus into minus 1 by 2 plus 1 by 2 plus 8 minus 4 is 4, and then minus into minus 1 by 2 is plus 1 by 2. Now see here, half plus half is equals to 1. 1 by 2 plus 1 by 2 is 2 by 2. 2 to get cancelled, 1 plus 4. So finally the value of I is equals to what? 5. Therefore, the integration value of this is equals to what? 5. I hope all of you understood.